the webinar now, and it will be archived and available for others to use on their own or in professional development situations. So the point of the cartoon here is just to add a little humor, but it also is an important reminder of the importance of the language we use for mathematics communication. So just a few technical items to go through. We have muted your microphones for the duration of the webinar. If you have questions, please type them into the question box, and we'll either respond to you in writing or during the discussion at the conclusion of the webinar. The phone number and the access code are provided if your speakers are not working well. But it helps if I'm on the right slide for you, so I'm going to go back one. Now it's provided on the slide for you. So if the webinar PowerPoint is not showing on your screen, there may be a little blue asterisk or flower symbol down towards the bottom of your computer screen. And if you click on that, that should open the program. So we will be conducting several polls today throughout the webinar. So to start, we have prepared 2 polls for you to answer regarding your participation tonight. So the first poll is in regards to how many people are participating in the webinar at your site. Okay, so it looks like the majority of you are participating on your own, but it does look like we have a couple people who are participating together in groups. Wow, and we've got one group that's more than 15. That's great. This activity really is designed to do with other people, but hopefully it will be useful to you both ways. So the second poll tonight is, what grade level do you or your group represent? Okay, so it looks like we have a pretty good breadth here. About half of you are K2 people, some 3-5 people, 6-8, K8, and some others. So that'll be good. We have a nice mix of people today. So the goals of today's webinar are to examine the progression of addition in the current Idaho state standards and in the newly adopted Common Core state standards. We'll do this specifically for grades K through 2 to provide a comparison on how the 2 standard documents were constructed. Then we'll examine a potential progression of addition strategies and models based upon the Common Core state standards for grades K through 6. Through this progression, we'll examine the student thinking or strategies that are being used and try to link all this back to the ideas learned in the MTI course. Thank you again for joining us, and we really hope that this is a beneficial process for everyone. So for the sake of clarity, the following descriptions and names will be used to refer to the 2 sets of standards that are going to be under discussion during the webinar. So for the standards that are in place, that have been in place for the past several years and are currently being assessed on the ISAT, those are going to be referred to throughout the webinar as the current Idaho state standards. The new standards that were adopted in the spring of 2011 for implementation in fall of 2013 will be referred to as the Common Core state standards. It is important to keep these 2 standards distinct for the present discussion. So the following timeline is outlined on the Idaho State Department of Education's website. As you can see from the chart, the Common Core state standards are to be implemented in the 2013-2014 school year. The new assessment of the Common Core state standards is designed by the Smarter Balance Assessment Consortium. This assessment will be fully implemented in the 2014-2015 school year. For more information on the potential design of the SBAC assessment, you can go to the Smarter Balance Assessment Consortium website with that link that's provided on the slide. The archive webinar will also be available on the MTI follow-up site, and the link to where that archive webinar will be located will be on our last slide, so you can get this link there if you decide you want it later. So this year's kindergartners will be tested on the new Common Core State Standards assessment in 2014-2015 as third graders. They will never be tested on the current Idaho State Standards or the existing version of the ISAT. The exact details and timeline regarding high school graduation standards still needs to be determined. My understanding is that the particular details still need to be decided at the state level. However, based on current requirements, the potential exists for current 7th graders to be required to pass the new assessment that is aligned to the Common Core State Standards in order to graduate from high school. So while the timeline does not require implementation of the standards until 2013-2014, the question arises, can we wait until then to begin implementation? We are not advocating an immediate shift from the current standards to the Common Core State Standards. The difference between these two standards documents is significant enough that to do so would probably lead to poor implementation if done too quickly. So the question is, are there aspects of the standards that can either be implemented now, or at least conversations that can occur at the school and district level that will assist with implementation? So today's webinar is designed to assist in those school or district level conversations around the standards for addition in kindergarten through 6th grade. So we'd like to conduct a poll now to get a feel of where your school or district is in their implementation of the Common Core State Standards. So the question we're going to ask is, where is your school or district in the process of implementing the Common Core State Standards? Okay, so it looks like we've actually got a pretty good mix in there, just starting to have conversations, some people just starting to implement, some people in the process. I'm curious to know what the other is, but I'm sure that's a good thing to understand. So let's continue on. So in order to begin a conversation about interpreting and implementing the Common Core State Standards, it is important to understand how they were constructed. The chart on this page identifies the domains found in the Common Core State Standards. These correspond somewhat loosely to the standards from the current Idaho State Standards. The current Idaho State Standards are organized under the headings of number and operations, which refers to the Common Core State Standard domains that are in gold on that chart. These are counting and cardinality, number and operation in base 10, and operations fractions for grades K through 5. The addition standards discussed in today's webinar come primarily from the number and operations in base 10 domain. Algebra in the current Idaho State Standards relates to the domain in blue of operations and algebraic thinking. Geometry in the current Idaho State Standards aligns with the geometry in the Common Core. And 2 areas of measurement and data analysis, probability and statistics in the current Idaho State Standards are condensed into 1 domain of measurement and data in the Common Core State Standards. One of the most important distinctions between the current Idaho State Standards and the Common Core State Standards was in the way the 2 documents were built. The current Idaho State Standards were built by grade-level teams of teachers and administrators who focused on identifying the content that needed to be taught at a particular grade level. This often led to an extensive amount of overlap from one grade level to the next, leading to a large breadth of topics being addressed at each grade level. In addition, the concept of progressions for a topic typically focused on increasing the difficulty level of applying a particular procedure or algorithm from one grade level to the next. The Common Core State Standards, in contrast, were built with a focus on learning and teaching progressions that focus on the content from one year building upon the content from the previous year. The following comparison may help between the current Idaho State Standards and the Common Core State Standards to illustrate this idea of a progression for the topic of addition in grades 2 through 4. So in the current Idaho State Standards, the second grade standard for addition calls for adding whole numbers with and without regrouping through 99. This requires the use of the traditional algorithm for addition. For third grade, the model stays the same. However, the number set changes from 2-digit to 3-digit numbers. Therefore, the progression from second grade to third grade is based upon increasing the difficulty level of the procedure being applied. However, the thought process or level of understanding does not necessarily change. In addition, the concept of subtraction is now added through 999 for third grade also. In fourth grade, the model is still the same. However, now the number set includes all multi-digit whole numbers. The progression in the current Idaho State Standards is based on increasing difficulty of performing the traditional algorithm for addition based on changing the numbers involved. This is a very traditional instructional approach to addition computation, and one that is commonly found in U.S. textbooks. So in contrast, the Common Core State Standards calls for a progression of the strategies and models being used in addition. For second grade, the standard calls for the use of concrete models or drawings and strategies based on place value, properties of operations, and/or the relationship between addition and subtraction, and then relating those strategies to a written method. So this is very similar to the ideas embedded in the inactive and iconic models that are discussed throughout the MTI course. A number line is an example of a potential model that could be used in second grade to address the addition standard. Several other potential models also work. In third grade, the shift primarily appears to be in the use of the word fluently, in terms of the use of the models for addition and subtraction. This means that students should be able to flexibly choose from a number of models based on the structure of the numbers and efficiently apply the model to solve the problem. However, note that the standard algorithm is not specifically called for in the standards. Arrow language and tree diagram, in addition to number line, are examples of potential models that could be fluently used in third grade. It isn't until fourth grade that the standard algorithm is called for in the addition and subtraction standards. Partial sums is a model that could be used in third or fourth grade and could provide an excellent transition for students to the standard algorithm. Please note that the progression in the Common Core State Standards calls for slowly increasing the formalization of the addition throughout the grades. This progression is supported by research based in students' understanding of place value and addition operations. One important thing to consider as you are transitioning to teaching the Common Core State Standards is that they are designed to address the issue of breadth that is typically brought up regarding U.S. mathematics curriculum and textbooks. In order for the Common Core State Standards to be implemented correctly, teachers must be willing to give up some of the items they currently teach at their grade level in order to achieve the depth needed to teach these standards. I recently came across several research articles on implementation of standards and professional development initiatives, and the research pretty clearly indicated that teachers are really good about adding new content to their instruction. However, they are rarely willing to give up a topic once they begin teaching it. So I'd like you to talk for a minute with your partner or group, or for, it sounds like many of you, reflect individually upon that idea. And then we have a poll built in to assess your thoughts on this idea. So the question is going to be, do you agree with the idea that the breadth of topics at each grade level is currently too wide? So take a minute to think about that and then answer the poll. Okay, so pretty good agreement on that idea. So we'll keep going and discussing some of that a little bit more as we go through the webinar. So now we're going to get back into the math a little bit. So solve the problem 492 plus 263. I'll give you a minute to solve the problem. Just like in the MTI course, please try to solve it at least 2 ways and find the similarities or differences between your methods. This was also one of the problems that was listed at the beginning of the webinar, so you might have already done some of the work around this one. Okay, so before we actually discuss that problem, we're going to do a quick review of some vocabulary, particularly for the terms strategy and model. So for the purposes of this webinar, we're going to define strategies as those mental processes we use to solve a problem. Model is going to refer to the method we use to notate our mental process or strategy. So a strategy often has several different potential models that can be used to explain what the strategy was. And it's often the role of the teacher to assist students in efficiently notating their mental strategy through a model. So what strategy, so that's that mental process, is being used here? So examine that model and tell me what strategy it is, and then we'll use the poll to answer the question of what strategy is being used. And with the choices, if you can remember back to the MTI course and the Rachel video, the ideas of counting all, counting on, decomposing, or compensation. Okay, so it looks like we've got some counting on, some decomposing, and some compensation. And this is definitely one of those times where probably a webinar format is not the best way to do some of the stuff that we like to do, because it's nice to be able to talk to people and understand how they're thinking about a particular problem. So I'll explain how I'm thinking about it. I would describe the strategy as counting on by friendly numbers. However, I would also include that idea of decomposing into the description of the strategy based upon the decomposition of the 263 into friendly chunks of 8 and 255. But I would be curious to know how other people are thinking about that, because I think there are different ways to think about the problem. So the next question is, what model is being used? So the model that's being used here is the number line. And one thing that we noticed in the presentation of the preparation for this presentation was that we actually hadn't done a very good job of keeping the numbers proportional for this number line model. The jump of 8 should be significantly smaller than that jump of 55. So while it doesn't need to be perfect, it is important to keep in mind the idea of proportionality when students are using a number line. If they no longer need the proportionality aspect of the number line, they can be encouraged to use a model such as arrow language. So the next question is the representation inactive, iconic, or symbolic? And I actually realized as I was doing this question that we don't have a slide in the MTI class to actually define these words, but it's something that we talk about throughout the class repeatedly. So we now have a slide. to define them. So hopefully the concepts are familiar from the MTI class. However, we'll do just a quick review here as a reminder. So the concept of modes of representation came from Jerome Bruner. And according to Bruner, learners have systems for processing information that results in one of these three representations: inactive, iconic, and symbolic. So in regards to mathematics instruction and learning, inactive refers to physical or action-based ways of representing information. Iconic refers to visual images that represent a particular situation. So it represents that inactive situation. And then symbolic refers to an abstract representation of a situation. Essentially, if a learner is not familiar with the meaning of the symbols, then the understanding of the situation cannot be derived from the representation. They have to know what those symbols mean. So I figure if you've managed to last this long through the webinar, it seems like a good place for a little bit of humor. So the cartoon actually does have a purpose in terms of representing the ideas of inactive, iconic, and symbolic. So if you were actually there in the fight that was occurring in the cartoon and involved in that action, then that would be considered inactive. And the picture of the actions that you can see on the cartoon are an iconic representation of that physical situation. However, the math on the board that involves all those symbols clearly has no meaning unless that has been formally learned. Therefore, that is a symbolic representation. So back to that number line example. This is an iconic representation because it provides a visual illustration of the situation that includes the magnitude of the jumps on the number line. So think about this question for a minute. At what grade level is the number set 492 plus 263 and the model of the number line currently taught in the Idaho state standards? So we'll come back to that in a little bit because we'll be examining what their placement is in the Common Core state standards in just a few minutes. So on to building the actual progression. You should hopefully have the two sets of cards for the following portion of the webinar. There should be a set of materials for each 2 to 3 people in your group. And the set of cards that had the 6 boxes to a page, so those are the larger size cards, will be used to create the chart that we have on the following page. So we'll take a minute for you to set up your chart, but I would set it up similar to this, where you've got your standards by the grade levels, you know, ascending or descending to the side, and then the ideas of inactive, iconic, symbolic across the bottom. I think you'll have to cut that card actually across there to separate those 3 pieces. And we'll just time it for a minute, and then we'll come back and talk a little bit more. Okay, so I've decided that we need like music or something to play during the pauses. So I'm going to guess that that's a bit about a minute. So while you're completing that outline of the chart, I want to return to that idea of inactive, iconic, and symbolic representations for the purpose of this webinar. So once a representation is put on paper, it can no longer be considered inactive. Therefore, as you're looking through the models in a few minutes, you need to consider how you're looking at the model on the card. If it's representing to you an image of students using like blocks or Unifix cubes to solve the problem, then it would be appropriate to include in the inactive area because you're thinking of it as a physical thing. However, if you're viewing the images as something a student has transferred to paper, that is then an iconic representation and should be included in the iconic area. This is somewhat confusing, but it really involves the mental image you're picturing when you're looking at the model. So this conversation has come up in several of the workshops that we have conducted on the progression, and we wanted to make sure it was delineated for you before we started, and it might make more sense once you actually get into the activity. So one other item for consideration is the placement of the last card in the set from the previous slide. It states, the range of models called for in the standards are based on the number sets and operations called for at that grade level. However, the models from the previous grade level will likely be present in student solution strategies in the next grade level. The intent of this card is to let individuals know who are creating or examining a completed progression that not all of the possible models for a particular grade level are present in the progression activity. You should feel free during or following this webinar to add your own elements or models to the progression to make it fit your understanding and thoughts about addition for a particular grade level or across the grade levels. Okay, so it's now time to create your progression. The directions on the slide are intended as a general process for creating your progression based on questions that have arisen in previous workshops. However, feel free to use your own process for creating the progression. What we're going to do is probably give you about 10 minutes at least to create the progression, but what we'll do is put a poll up in about 8 minutes to figure out where you are in the process. In the meantime, if you have any questions, please type them into the question box, and we'll try to address them as you're creating your documents. You can also call us at that phone number that's listed on the screen if you've got questions that might be easier to answer on the phone, then we'll just answer the phone in our office here and try to help you with some of those. But really the idea is that you might want to sort those problems into piles just based on the number sets, then figure out what grade level do you think those fit at based on looking at the number set and that model. Then once you kind of get that figured out, looking at a particular grade level, what order do you think those models would potentially go in? Maybe according to that inactive, iconic, symbolic idea, or you may have a slightly different way of thinking about it. And so you're just trying to look at what's the progression between the grade levels, and then once you get that, what's the progression within a grade level. So we'll start now with the 8 minutes, and we'll put a poll up at about 8 minutes to see where you're at. Thanks. Hi, so we're going to launch a poll just to get an idea of where you're at in creating your progression. Thanks. Hi, so it looks like about half of you are done. Some people are almost finished and some people are halfway. So how about we take about 2, 3 minutes and we'll then continue on with the webinar. The people that are very confused, if you want to type in a question to us, we'd be happy to help if there's anything we can do. Thanks.
Okay, so this is Jackie Ismail. I'm going to be taking over for the second half of our webinar, and Michelle will be answering questions. I'll give you about a minute to finish up your progression, and then we're going to take a look at a few sample progressions. Okay, so we're going to go ahead and get started. We're going to look at some sample progressions that groups have come up with in past workshops. We'll break it apart by looking at the K1 portion, the 2nd through 4th grade, and the 5th through 6th grade separately. Note the placement of the models in each progression. Look for what might be similar or different from your progression. We will also highlight a few differences and discuss why they may have been placed that way based on student thinking. We will start by looking at the kindergarten and 1st grade portion of the progression. Here are 2 samples of the way models have been arranged by participants in past workshops. Compare the K1 sample progressions with your progression, noting any similarities and differences. What might the thinking have been behind the different placements? We will pause for a minute to let you compare. Okay, take a few more seconds to look, and then we're going to launch a poll asking if your progression is most similar to the top progression, the bottom, or not like either. Okay, so it looks like we're pretty split between the top and the bottom, and we have a few people that their progression doesn't look like either. Depending on how we're seeing the models, past experience or student thinking may provide us with a variety of ways to build the progression. Let's look at a few places in the sample progressions. Note the placement of the models circled on the slide. Both of these placements have come up in previous workshops. Can you think of a reasoning for each placement? I'll give you a few seconds to compare the 2. Okay, in the top progression, the participants explained that they were seeing the number path as an inactive mode of representation, where students would be able to count each box and physically move from one to the other. So that's this piece right here. They then saw this transitioning to either a bar model or a number line, both of which would be iconic representations of the quantities in the number path. The thinking on the bottom placement was that moving on a number line or path, which could be similar iconic models with each number represented, could then transition to a bar model without every number represented. Let's look at a second difference in the placement of the models. For this one, arrows have been added to show where the participants saw the model moving next. I'll pause for a few seconds to let you take a closer look and think about the reasoning behind each placement. Okay, so our top progression, the participants saw this as inactive with base 10 blocks leading to counting on the number line, so taking the quantity of 38 and then counting on with the 7. The bottom progression, these participants saw the same inactive base 10 blocks, but decomposing by place value, which would lead to the tree diagram. The difference shows the needs to be aware of student thinking as we are using base 10 blocks, so we can find a context and models that will help fit the way that students are combining those quantities. We are now going to move to the 2nd through 4th grade portion of the progression. Again, we have some sample progressions that have come up in past workshops. Compare the 2nd through 4th grade sample progressions with your progression, noting any similarities or differences. What might have been the thinking behind the placement of the different models? We will pause for a moment to let you compare. Okay, so in just a moment, we're again going to take a poll to see if your progression is most like the top, the bottom, or not like either. Again, it looks like we're pretty spread out. A lot of this has to do with the way we're seeing the models, experience with students, and different number sets. So again, let's take a look at a few differences in the placement of the models and explore the reasoning behind the placements. Our first difference is the same as the one that we looked at in the K1 examples. It's the difference between inactive with base 10 blocks leading to counting on a number line versus the base 10 blocks leading to decomposing by place value. Again, the importance of listening to student thinking is emphasized here and can affect the next step in the progression. Here's a second place where we notice a difference in the placement of the models between the two sample progressions. See if you can determine what the difference in strategy might be that led to the different placements. Both are decomposing one of the numbers and counting on, but how are they decomposing the numbers differently? I'll pause for a few seconds to let you take a closer look. Okay, so hopefully you had a minute to look at the difference between the two. In the top progression, the participants saw decomposing with friendly numbers coming before decomposing by place value. We see this as the students add 8 first to get to 500, which is a friendly number and easy to count from. In the second progression, the participants saw place value coming before friendly numbers. We see this as the students decompose the quantities by hundreds, tens, and ones to count on. Past experience and number sets can affect what students may do here, so it may be possible for us to see either one of these. Finally, let's look at one more place in the 2nd through 4th grade part of the progression. One area is circled on the screen. What is the shift that students are making to move from counting on with models like the number line or arrow language to using a model like the tree diagram or partial products? I'll pause for a few seconds to let you investigate the shift in student thinking. Okay, so let's take a look at that. They move from decomposing one number with the number line and arrow language to decomposing both numbers, usually by place value. This is an important shift for students to make to get to models like partial products and eventually the traditional algorithm. Finally, let's look at our 5th and 6th grade portion of the progression as we explore our last number set, decimals. Compare the 5th and 6th grade sample progressions with your progression, again, noting any similarities or differences. What might the thinking have been behind the placements? We'll pause for just a moment and then take one more poll. Okay, so here's our last poll. Is your progression similar to the top, the bottom, or again, not like either? So it looks like just in the other two portions of the progression, we see a range of the way that people arrange the models within their progression. Let's take a look at a few different placements in the 5th through 6th grade. Take a few seconds to look at the difference in placement of the compensation strategy that's circled in both progressions. What do you think the participants would have, why do you think the participants would have placed it differently in their progressions? Okay, so looking at the two different placements of compensation, the progression on top has compensation showing up with the partial products and other decomposing methods. This group felt that compensation with this number set would occur when students have had the chance to explore place value and finding friendly numbers, which had happened earlier in the progression. However, the bottom group has compensation coming at the end of the progression with this number set. They thought compensation can look differently depending on the operations and number set. We may see students compensating earlier in some cases, but the ability to compensate with a variety of number sets requires flexibility and a solid understanding of the number set, which is usually built through the use of the other models and strategies. Our last difference in the 5th and 6th grade portion of the progression is the same as the one we saw in the 2nd through 4th grade examples. The top has decomposing and counting on using place value coming before friendly numbers, while the progression on the bottom has decomposing and counting on with friendly numbers coming before place value. Knowing that students are coming from where they're coming from and their understanding of addition with whole numbers may affect the way in which these appear in the progression. There is definitely work that must be done with an understanding of this new number set before we ask students to operate with meaning, and that understanding may affect where we see this happen in the progression. So let's take a moment to reflect on what we have done during the webinar. What big ideas are you leaving with? Take a minute to discuss with your group or reflect on your own, and type any responses into the chat section. Okay, so there are multiple big ideas to walk away with from this webinar, and several were mentioned that are fantastic big ideas. Here are just a few that we thought about. It is important to know models appropriate for your grade level standards. Reflecting back on the difference we see in the Common Core standards compared to our current state standards, it is important to know models that will emphasize place value, properties, and the connection between addition and subtraction. Once we have an understanding of this, we can then find contextual problems that will encourage the use of these models. A second big idea is knowing what is happening before and after your grade level can help guide instruction. We need to know what knowledge students have gained in previous years so we can build on what they know, and by knowing where they are going in future years, we can better prepare at our grade level. We also know that not all students come to us or leave our classrooms at the same place. So by knowing what is happening before and after our grade level, we can better meet the needs of the range of students in our classroom. And last, there is not a perfect addition progression. We can have general ideas, but models and strategies may fit in different places based on the students, the task, or the number sets. So which of these statements are you leaving with? I'll give you a minute to look at the difference between the two. Hopefully you're leaving with the bottom statement. It is important to know the models appropriate for your grade level standards so we can then choose tasks that will encourage students to use those models. For example, if we want students to use a number line, we may give a problem about a race so their model will fit the context. We then want to discuss strategies represented in the model and compare students' use of the model so they are able to explore the benefits and limitations of their chosen model. Finally, let's take a look at the 5 big ideas for building mathematical understanding and where they came up in our webinar today. We'll start at the top with taking students' ideas seriously. As we look at the different possible progressions, it's important to listen to student thinking so we can help with models that fit the way in which they are thinking about the numbers. Moving to pressing students conceptually. Knowing what is happening in grade levels before and after us helps to press students to where they need to be in the progression through the problems we pose and questions we ask. Encouraging multiple strategies. A range of models and strategies allow for more connections and greater flexibility with number. Addressing misconceptions. We didn't spend much time here, but a very important part of students moving through the addition progression is taking the time to address the misconceptions that may arise. And finally, focusing on the structure of mathematics. A deep understanding and flexibility with number is important for students. This can be developed through the use of different models and strategies and reinforced as we explore the limitations of those models and apply them to a new number set. So before we wrap up, we wanted to let you know about a 1-credit opportunity for the webinar. All of the information is on the slide and will also be posted to the State Department of Education's website under the MTI page. That link is towards the bottom of the slide right here with information. Any questions that you may have, you can contact Nicole Hall at the State Department, and her email is on the slide, and she'll be able to help you with any questions you may have about the credit. Okay, so to wrap up, we just wanted to thank you for attending our webinar. We will send you our presentation and a link to a survey about your webinar experience. We appreciate any and all feedback so we can continue to make these better. Information and a link to the archive and a facilitation guide will be on a follow-up site in the coming weeks. We would love to see your progressions and be able to share them with the participants in the webinar. So if you're willing to share what your group did tonight, please send a picture to either Michelle or I, and our contacts are on the screen, and we will get them posted with the webinar information.
Hi, this is Michelle Carney. I wanted to make one last comment that we think it'd be a really good idea if you took this webinar and or just the idea of the progression and facilitated it as a conversation back in your school. So just kind of keep that in mind. We'll have all the materials posted, and I think it'd be a great opportunity at a school for people to have this conversation at either a K-5 or a K-6 level. So just wanted to make sure we kind of ended with that idea so that you guys could consider doing that back in your schools. So we'll stay on the line for a little bit and see if there's any questions. And we really appreciate you taking the time to be here today. So just log off when you're ready. But if you have any questions, please type them in. Thanks.